Our definition of science that we talked about a couple of days ago said a systematic study of the universe to produce observations, inferences, and models. And so today we're going to spend some time talking about what a model means. Now you may be familiar with maybe model cars. We can build models of lots of things. You can build a model of a log cabin. You can build model cars. I know that when my boys were younger, they really enjoyed building model almost anything. Here's a model tank that one of my boys built. You can see that it's really been painted and it has lots and lots of detail on it. One of my boys really enjoyed building model ships, and the detail that they put in these things. I mean, they were actually using tweezers to stick some of these pieces on here because they were so tiny, and this particular son, his hands were really large, and so he had to use tweezers to be able to position all of these little guns and all sorts of stuff like that on this model. And so the detail that some of the models have is just absolutely amazing. But what's true about a model is that no matter how good this model is, it doesn't function like an actual tank would in reality. It doesn't actually shoot anything. You can't actually drive it. Just like the boat, it may have these little model planes on the side. Since this is an aircraft carrier, they may have planes on the side of it. These planes aren't actually going to fly. If I put this in the bathtub, it's going to sink. Okay, so it is a model, but it's not the real thing. And so the models that we create in science are similar to these kinds of models. They help us to understand the real thing, but it is a representation of the real thing. So what kind of models have there been in science? Well, the one that your book specifically talks about was a model of the universe. And we started out with a model of the universe that said, okay, the earth is at the middle and everything revolves around it. Well, the more we studied and the more we knew, the more we realized that that model wasn't consistent with some of the other things that we were observing about planetary motion and different things that we were seeing. So that model was revised to make a model where the sun was at the center and everything revolved around the sun instead. The atomic model, a model of what an atom looks like, is very similar. One of the very first models of an atom was made by Bohr, and actually even before Bohr, they thought that an atom was just like this blob of pudding, and it had electrons kind of jammed into it like you'd stick raisins into an oatmeal cookie, and they just got stuck in there. Well, the more they studied about atoms and how they behave, they realized, okay, this model didn't work, so now we've got to come up with a different kind of model. And so Bohr came up with a model where the electrons actually orbited around the outside. And then the more we studied there, we realized, okay, well, that model doesn't quite work either, so we're going to update the model again to something different. We'll talk about a lot of those models in detail when you study chemistry. So a model is a workable explanation or a description of a phenomenon. And the key here is that it has to be workable. And so if you come up with a model, for example, the one of the universe, and you say, okay, well, it doesn't work to always put the earth at the center, because then this planetary motion that I'm seeing over here doesn't fit with this model, so I have to change the model. So everything's great until it doesn't work, and then you've got to change it. So that's what I mean when I say a workable explanation. It's something that has to function with everything else that you know about this particular thing. So a workable explanation or description. And the key thing about a model is that the models are going to change as our knowledge changes. The more that we grow, the more that we know, the more that we learn, the more these models change. The models of cells have been evolving very rapidly. A model of what DNA looks like changes all of the time because of the new things that we're continually learning. So the key here is that models are going to change as our knowledge changes. There are two types of models, and that's what these lines coming down here were supposed to refer to. It's a model, and it's coming down into two types. There's either a theory or a law. And this is defined a little bit differently from what I have seen in other books. So make sure that if you've learned this another way, that you're going to learn this in this particular context, and don't get this confused with something that you may have seen before. So a theory, as your book is describing it, is saying that it explains something and it's used to predict future behavior, while a law describes something in a particular circumstance and it's often expressed with a mathematical equation. Let me give you a couple of examples to help you understand what that means. A theory would be something like this. If I push on an object, it moves. Okay, if I push on an object, it moves. The harder I push, the faster it goes. Okay? The harder I push, the faster it goes. When my kids were smaller, we had an office chair that had wheels on it, and they would like to take turns pushing each other around on this chair. So one would sit on the chair, the other kid would shove the chair as hard as he could push it, and then they'd see how far across the room they could make them fly. I wouldn't necessarily recommend that, because sometimes when the big kids started pushing, the little kids rammed into the wall. So that's something you do when mom's not around, right? Okay, so the theory then is if I push on an object, it moves. The harder I push, the faster it goes. The law, the mathematical law, is expressed as F equals ma, which stands for force equals mass times acceleration. Now, this is not something I expect you to know right now. We're going to get into this much, much later. But what I'm trying to show you is the difference between this explanation, which is done in words, and this law, which is expressed as a mathematical equation. They both say the same thing, but they're expressed a little bit differently. Okay? Let's look at another example. If you've ever had a party, and maybe your parents have had balloons at the party, and you take the balloons outside and it's cold. Have you ever noticed what happens to the balloon? Well, if you take balloons that you've blown up in the house and then you take them outside on a cold winter day, the balloon is going to shrink because of the temperature. And so what you might say here is that if I decrease the temperature of a gas, because there is gas in a balloon because it's air, if I decrease the temperature of a gas, the volume decreases. Okay, and that's evidenced by, again, if you take a balloon outside on a cold day, it shrinks. You decrease the temperature and the volume of the balloon goes down. So here I've explained it in words, but I could also explain it in terms of an equation. B1 over T1 equals B2 over T2. Again, this is not something I expect you to know. I'm just trying to explain to you the difference between a theory and a law. A theory puts it into words, and the law puts it into a mathematical equation, so I can actually calculate, well, if I drop the temperature by how many degrees, then how much is the volume going to go down? If I push with a certain amount of force, exactly how much faster is my mass going to move? Okay, so this is a generality. It says, it explains a concept and it's used to predict what will happen. This is going to describe it for a particular situation. If I decrease it this much, then the volume goes down this much. If I push this hard, the object's going to move this much faster. Okay, so that's the difference between a theory and a law. This is kind of, you can think of it, this has been used in words. It's going to predict something. This is going to describe it for a very particular situation. Okay, so two types of models, theories and laws, and those models are going to continually change as our knowledge about the science changes.